Hi, I'm Matthew Fetty, and I'm from Dr. Jean's Lab Chem Section 4. So today, we are going to go over the chemical equation, which is going to be citric acid, which is C3H5O, COOH3, and that is in parentheses, and then plus sodium hydroxide, and then that produces citric acid, which is Na citrate acid, my bad, sorry. Na3C3H5O, and then that's plus H2O. Now this one has a 3, and this one also has a 3. Now we are going to put the states of matter over here. So we have aqueous, which means it dissolves in water for sodium hydroxide, and for citric acid. And then this one is a liquid for water, and this one is aqueous. Now I'm going to show a sample stoichiometry. Today I'm going to show the sample calculation of stoichiometry for the citric acid. So we start off with 0.0186 as our liters, and then we are going to try and find the moles of the first NaOH. So we start with 0.813 of molarity equals moles over liters, so it would be moles over 0.0186. And this you cross multiply, so this would mean moles equals 0.015118. Now we're going to put this into our stoichiometry, so 0.015118 of moles of NaOH, sodium hydroxide, and then we're going to use our balanced equation over here to get moles of citric acid. So that's 1 mole of citric acid, as seen in the balanced equation, over 3 moles of NaOH. Now, this is going to equal 0.0050406. And we started over here with 2 milliliters of the juice. So that means we're going to put this over 0.002 liters instead of milliliters. And that comes to 2.52. That is a concentration of our first lemon juice sample. Now, we're going to show the average of all 3. So I am going to erase this for more room. So I'm going to give you one last look of my calculations, and then I am going to erase it so I have more room on the board. Now, we're going to show the average of all 3. So that's going to be 2.52, as we just found. That's going to be 2.47, which I calculated before the video. And that's going to be 2.52 again. Very similar. Now, if you add all 3 of these up and divide by 3, our average is 2.50, and that is our average composition of the concentration of the lemon juice. So now, we are going to find the equation for pH, which is going to be negative log, and then in brackets, it's going to be H+. So that is the equation to find pH. So now I'm going to show you the differences between the pH for the lemon juice sample before and after. So as you can see, the pH goes up, and that is due to the OH being released into the citric acid, so that's causing more OH to go in, causing the pH to be higher. So now I'm going to show you the calculation to how to find pH. So that's going to be negative log, so pH equals negative log, and then in brackets, H+. That's the amount of H+ released. So that is the equation for how to find it. And then the concentration is going to go up because of all the OH being released into our sample. That was my presentation. I'm Matthew Fetty from Dr. Jean's Lab 4, And my references are the lab manual, the CRC handbook, and that's it. Thank you.